Okay, we're having this nice integral. To prove it, we are going to use integration by part. We take u is equal to x to the n. Before there was du is equal to what? Nx to the n minus 1. I know you know that. Okay, we take our dv. You can use the di method. I will just drop it here. dv is equal to what? 1 plus x square root of this. Therefore, v is equal to what? 1 plus x. So this is equal to 1 plus x, or that to the power half. Okay, integrating this, I'm going to be having what? We add the 1 here. That is 1 plus x all to the power 3 on 2. We put 2/3 here. That is the all over 3 on 2. We invert and have 2/3. Okay. We substitute it back in the initial equation of integration by part uv minus integral of v du. Okay, here we have a limit 0 to 1. Substitute it back, we have u being what? So that is x to the power n. We're going to be having that will be equals to x to the power n uv. Okay, 2/3 1 plus x, that is 2 over 3 into 1 plus x to the power 2/3. Okay, if we limit from 0 to 1, we can just directly solve this one. Substituting 1, we're going to be having x 1 to the power n is 1. Okay, 1 1, and that is going to be having that is equal to what? 2/3. 1 plus 1 2, that is 2 to the power that is the square root of 2, all that cube. Okay, minus integral of what? V du. What is our v? 2/3 1 plus x all that cube 2/3 1 plus x all that to the power 3 on 2. That is from 0 to 1 du n x to the power n minus 1. You can just bring out this 2/3. Okay, let's just bring out this 2/3. Let's erase at this point. Bringing out 2/3. I'm having 2/3 here. Integral from 0 to 1. Okay, we are not going to further integrate since our initial equation is looking like I to the n and I to the n minus 1. From here, you just know that you cannot integrate further because you have already the first I to the n minus 1 from the first integral. If you have I, substitute n minus 2, you know that you have to integrate twice to have the final answer. But since you have 1, you know you have just one integral, and that is the first integral. And we end at this point. Yes, what are you going to do for next? To have what you have up here, since it's a proof. Okay, you have 2/3. We just keep this side. Okay, just keep this side intact like this, and consider most on this, and focus most on this other side. You have a minus 2/3 integral from 0 to 1. Okay, 1 plus x to the power 3 on 2 can be expressed as what? 1 plus x times 1 plus x all that to the power half. For minutes, if you have 1, by adding it to come back, you're going to have 3 on 2 times n x to the n minus 1. Okay, from here we can expand. Also have the I to the n and I to the n minus 1. This n minus 1. That is I to the n minus 1. Multiplying by 1 and multiplying by x. Therefore, 1 times this and x times all of this. We are going to be having what? We can bring out this n in general. That will be equals to, that will be minus 2n all over 3. Integral from 0 to 1. We take the first one, that is 1 plus x. 1 plus x to the power half times x to the power n minus 1. Here, that's the first one. Plus, you can just put the plus down here. Integral from 0 to 1, because integral of a plus b is equals to integral of a plus integral of b. Hope you know about this. Okay, you can just keep the gx, don't forget about that. Okay, it's a gx somewhere. Taking the other one, the same thing, but with an x. That is 1 plus x to the power half times x times x to the power n minus 1. Okay, And this x to the power 1 can just go, and you have what? X to the power n to the power, just keep it like that, x to the power n minus 1. That is what determine our answer. Okay, we then proceed by having, that is I to the n, I copy I to the n, I subscript n is equals to what? To that square root of the square, all that cube, minus 2n all over 3. Okay, we have the first integral. Okay, we have this point. Okay, just keep it like that. Just erase. There's the first integral that is okay. At this point, you can even remove it. Let's just remove here. We are going to be having x to the power n. That is in it, x to the power n. This negative x n minus 1 here. That will be minus 2n all over 3. Since this is a generalized one, taking everything, 2n all over 3. You can take this as what? I to the n minus 1, because it's exactly the same thing as I. What is our I? Where is this n? And on that side, you have n minus 1. Because if you substitute n minus 1 here, we are going to be putting minus 1 here. And that is equivalent to what we have here. That is I subscript n minus 1 plus this is equivalent to I to the n. I subscript n. Okay, therefore we are going to be having I subscript n is equals to 2/3 root 2 cube minus 2n on 3 I n minus 1 plus I n. From here we can multiply by 3 so as to have what we want. 3 I n is equals to 2/3 square root of that cube minus 2n I n minus 1 minus 2n I n. Okay, we can bring this, what do we have here? 2n plus 3. Okay, we can bring it here. That will be what? 2n, okay, plus 3. You keep the in being equal to what? 2 root 2 all that cube minus 2n I to the n minus 1. Okay, and that is exactly what we had. Okay, looking at this, we have a 4 here. The question then is, how do you have that 4? From indices at this point, you can just have 2 root that, all that cube is equals to 2 root 2 root 2 root 2. Multiplying this, you have 2 times 2 times root 2. That is equals to 4 root 2. And you're having, we come back and substitute it here. And we have finally 4 root 2. And cured ED. Take a look at this next video of this one, and we see you there. Goodbye.